If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You're listening to AFM radio on astronomy.fm, around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is astronomy.fm.
The pirates are coming. The pirates are coming. The pirates are coming. You better watch out.
Arr.
Arr.
It's Space Pirate Radio time here on astronomy.fm radio. That means it is another Wednesday night, and this one is June the 19th, 2019. There's no pattern to that, is it? No, okay. 2019, 9 o'clock in the evening. Oh, it's kind of a 999 thing. 9 o'clock in the evening. For those of us here in the eastern portion of North America, with a little added daylight savings time going on here. It's still light outside. Well, we'll talk about that a little bit later. Universal time would put it at 1 o'clock in the morning, June the 20th, Thursday morning, UT. Around the world and back again. Crossing the international date line. That's what time it is right now. Or not. So we're live anyways, and of course, this is the time we always have our chat room active. It's always open, but come on over to the chat room. Just go to the homepage, astronomy.fm, and you'll see where you can get into the chat room. Join us. You're part of our crew on this Wednesday evening when you're in our chat room. And so far, we've got Aquafew, we've got me, Twist Edge, Glenn, Black Project, Plaid Mac, Plaid Joan, got you, Diane, and Evil Spock, always waiting for more people to join us before even while we're setting sail across the universe and beyond. All right, so I got some big news for us here. And no, it's not the sun. It's not the sun exploding. No, the sun doesn't even let off little firecrackers lately. So it's been dead for a month. So how did I start out with the sun anyways? So
As you normally do.
Exactly. So yeah, 30 days, no sunspots. Pretty quiet stuff. A little bit of solar wind, slow but heavy particles, because I think there's a little bit of a coronal hole in the sun right now. So it's letting some extra stuff through, but definitely not real fast stuff. Unviewable activity. Might get some auroras, but live near the poles, but away from all the sunlight up at the poles too. So that's not good. We'll talk about that.
At least at the North Pole, yeah. The South Pole's a little better positioned right now.
It is, yes. But we'll get back to that. But let's go to the big news, and that is, let me put the link into our chat room here. Here it comes. This is a good reason to get into the chat room, because when I reference an article that I find on the internet, I put the link to it, and you can read it fully on our Facebook page. That's where it'll get posted later, or in our chat room during our live presentation like this. So the American Astronomical Society has, or I think they've finalized it, purchased Sky and Telescope magazine.
Yep.
So what changes are going to occur? I don't know. I looked at the website, and they still look the same. The website for Sky and Telescope doesn't mention it. Those of you listening in, I went to the American Astronomical Society's webpage, which is aas.org, and there it was pretty much right at the top, the news from the executive office talking about. It's a long article, so I only read a little bit. I won't want to get into the whole thing anyway, so some of it's just kind of reminiscing of how the executive, got their first telescope type of thing. So I have some original copies. I have the original of the Sky and original of the Telescope magazines before they combined together. I've got just talking before the radio that I need to really go and write down all the stuff that I have and see where my gaps are and see what if I can get them completely filled. They're still available out there. They pop up on different astronomical marketplaces, things like that. So you can still get a copy of a fair amount of old Sky and Telescopes, including some of the pretty much originals. People just don't want them after a while. I don't know why, but
Yeah, and sometimes you can get them when old astronomy buffs are cleaning out their closet.
Yep. Or did you say a late astronomy buff?
Late
Sometimes,
astronomy buffs, too. Sometimes people are deliberately purging things that they suspect they will not need for the remainder of their lives.
or their
And
family.
sometimes the family is, I don't know what to do with 9 boxes of magazines.
Yes. So the old ones are pretty interesting to use, different points of view of things that happen, but a little bit of history too is in there. As I was going to go find one magazine when I saw an article about the moon and the invasion of Normandy.
Oh, wow.
And it didn't sound right at all. So I was going to dig up my old sky and telescope for, back around 44, 45. But then I don't think I ever found it. But I ended up checking some other sources and comparing the article of what I thought was incorrect information. Yeah, we talked about this a little bit before. It was just discrepancy in the interpretation of how somebody was not reporting history, but what they reported about their plans for the Normandy invasion. And the mention was with the moon. They said they wanted a late full moon, and it got reinterpreted like 10 years later as they wanted a late moon. So they basically, it was based on gliders. They were tow gliders with troops in them because they're nice and quiet. They would fly them across the channel and land at nighttime. And they didn't want them to be seen in the daytime, but they wanted them to have some moonlight, but not too early. So the timing had to be just right. And one article is reporting that a late moon would be like, waning crescent early in the morning. Said, no, that's not right. They wouldn't want that. So reading back to the original paper, said they wanted a late full moon. So you could have a full moon for approximately 3 days, really close, within a couple percentages of being full on either side of it. So I think it's kind of an old phrase of 3 days of the full moon. So one of them will be directly opposite of the sunset. Okay, but the day before that, it will actually rise before the sun sets. And then you'll have the truly full moon will rise right at sunset. And then the late full moon will rise about an hour after the sun sets. So that's what they wanted. They wanted the later full moon so that they would have enough moonlight to be able to land, but not be... and still be at nighttime and have the moon up where they could actually, land when it's kind of dark, but still have basically the whole full moon to see as much of the ground as they possibly could. And I was going to check my historical or my sky and telescope written back in that time and find out what they said for when the full moon was. But like I said, I figured it out another way.
I think you should, yeah.
Yeah, I did figure it out another way. I figured it out with Stellarium, but I wasn't sure if I really trusted Stellarium because sometimes things like that get inaccurate. But like I said, after rereading the article, I understood where the error was in some of this. So.
Yeah, there's a parallel to that. So as you all know, I was not live last week. I was down in Tennessee visiting family. Mm-hmm. And one of the things that I visited down there is a Mississippian mound building culture settlement about half an hour across the river from Memphis, which is where I was. Mm-hmm. And so we went there and checked it out. And it's a very interesting site, not because of the size or complexity, because there are many larger sites, but because, it was preserved under the ground because a sawmill was built on top of it, and a sawmill town rather than it being plowed up for farming. Mm-hmm. So you can still see the mound, and they found the remains of 400 settlements, and they found artifacts and whatnot. So that's cool. Mm-hmm. But even more interesting is that it is believed that this site, it's called Parkin in Arkansas, is one of the sites visited by the Hernando de Soto expedition, which was a mid 1539, 1540 expedition through the southeast of what's now the U.S. And it's rather significant because they were encountering cultures before we presume the introduced diseases killed them all and left us with no written language, no maps, no anything. So
no perishable artifacts.
Right. So being able to identify one-to-one, the Spaniards met these people, wrote 3 different accounts in Spanish and Portuguese, and it maps nicely to the site that we've got with the river and the moat and the mound and the remains of what appears to be a cross that the Spaniards erected, which is cypress wood, it preserves really well. So it's like, that's all cool. Yeah. But in the course of, verifying that the site was what people think it is, I found out that the historical idea of where these Spaniards traveled for, 3 odd years is really messed up, because the initial people who translated their diaries into English maybe weren't the best at speaking Spanish and Portuguese, number one. Yes. 2, were not naval people and did not have a really good grasp on how Spanish 16th century mariners reckoned the coastline. Which apparently was from the shipping lane rather than from the actual, what we would consider the coast where the water meets the land. So they were miles off, like 30 miles off. And they didn't understand how the moon actually would have been when they're translating these things in the 18th and 19th centuries. Whereas now we can look back and verify with programs like Stellarium. We've got, okay, so what was the moon phase in June of 1639? And we've got it. And they didn't have that. So it's like, astronomy and history intertwined. Fascinating. If I had some spare time, I'd be like, and if I knew Spanish or Portuguese, which I don't, I'd be like, man, that would be one heck of a project, is decoding the moon phases correctly. Yeah.
A lot of the translations are really tricky for a lot of old texts like that. So it might have gone from Portuguese to Spanish to French to English, and then that was Old or Middle English time. So a lot of interpretation gets really scrambled along the way, and just trying to translate the same word sometimes. They have different meanings, so a lot of it changes. And then dates too. The older you get, the far back. If somebody writes down it happened on June the 19th. Well, that June 19th might not be the same type of June 19th that is
like
now.
For instance, the Soto expedition would have been using the Julian calendar rather than the Gregorian calendar. So if you've got an English person post, I think it was 1732 when the UK and the colonies adopted it, translating a Spanish diary from the 1640s, you might have a problem right there. Yep.
So it gets a little tricky to trace things back. Plus, there were the times when the calendars got adjusted, so certainly can be off by several weeks, even though it was the same, listed as the same date. But if you count backwards, it's accurate. But if you start at their time and go forward, it doesn't come out to actually today's date. You know what I'm saying? Because days have been added and subtracted along the way to adjust the calendar and stuff like that.
Right, most notably the 10 days that were added to turn the Julian calendar into the Gregorian one.
Right, and then there's, leap years and stuff like that.
Yeah, leap years. I mean, actually, the Julian Gregorian thing is got a lot of relevance to my life, because my spouse's grandmother was born under the Julian calendar in what was then the USSR. So her birthday was 10 days off. So that makes reconstructing legal records fun, because sometimes her birthday is cited as December 30th and sometimes it's January 12th. Yeah.
And also, the farther back you get, like things like dates of birth don't get recorded for 6 months or more.
Yeah.
Somebody was born in the middle of summer, and then it's not until they get in, back into town or to the church 3 months later, and then try to remember the actual date that somebody was born on. It switches around a lot too, like that, or even a couple of years.
Right. Well, you had cases where people were, their birth was noted down in their christening day, which might be 3 days after their birth. It might be if they were frail the day of. It might be months after the fact.
Yep, it could be 3 months after.
And I even noticed a case I forget what cul-de-sac I was looking into historically recently, but it was a case of a known historical personage of not astronomy related. It was one of my history tangents.
Okay.
They were born on the day prior to their grandfather. So their official birthday that was written down in the logs was their grandfather's birthday the following day, even if that wasn't the day they were born. You could do that sort of thing.
Yep. And that's why a lot of people, of course, back then didn't know they were basically alone, orphans and stuff like that. They didn't know their actual birth date. The farther back in history you get, that happens quite a bit.
Well, yeah, and some people didn't know their actual age.
Right. Yep.
Not just, the day, but it's like, well, I was born in spring. When? I don't know. Year whatever of King So-and-so's reign.
Mm-hmm. Or might be related to a local village holiday or something that they heard later from friends, distant relatives, stuff like that.
Might be when the crops were being planted. Oh yeah, it was asparagus season.
So a lot of the farther back in time you get for history, the sometimes the less accurate it can be.
Well, and sometimes even into the 20th century, because a lot of it was like society role-based, class-based. And then, wars happen, records broke down.
Where records are written, churches burn down. That happens a lot.
Yeah. So reconstructing that kind of thing is all kinds of fun. But it helps to know, it really helps to not make the assumption that people did reckon things as we do today. And like I said, that where and to take into account the corrections for things like the moon was not what you think in relation to the calendar. Sorry.
Right. Yep. They might give an historical note. They might say the moon was a certain phase, and they might say it was a certain date. And if you try to go chase it back in a computer program, they don't match up. Now, I would suspect that the phase of the moon is probably accurate, but the actual date maybe not so accurate.
Right.
Yep. A lot of stuff like that in history. So that's why. Well, that's one of the reasons why I wanted my magazine that was from 1944, so I could actually, instead of just trusting the computer program, I could verify it with a publication that was actually published that month in April 44 or something like that. I could actually pull out one of those publications and check it out. I didn't get to it, but I didn't think I had to after a while. So anyways, scanning telescope. We'll see what happens when another organization takes it over, see if they change their format, stuff like that. I just looked at scanning telescope webpage. I don't see any mention of the change of publisher.
Yeah, they did. They do have a message. Actually, I posted it to the chat room.
Do they? All right.
Yep.
Let me check your link and see where is it? Okay, that's no, I don't see your. Oh, okay, this one. Oh, like Black Projects put one in, and you put one. Okay, gotcha. All right. So we'll see what changes. Always hoping for the best, of course, and we'll see if we get some explanations as to why the changes. Of course, they said I didn't get a chance to read the articles fully, so stuff happens like that. It's not like, hey, there was a merger 60 years ago or more.
Between Sky and Telescope, yep.
Yep, between the Sky and the Telescope, yep. All right, so look for potential changes in that the publication. All right, let's see where we want to go from here. Oh, you got something that you want?
Yeah, I was taking a walk down memory lane last week when I was down in Tennessee, and I found things like this set of flashcards that helped get me interested in being into astronomy when I was very small, 3-4 years old.
Okay.
They were water damaged, and only a few of them survived, but they were really cool. They were like 1970s kind of trippy. Half the card was a stylized star map, and the other half was a really evocative illustration of Andromeda or Perseus or Canis Minor, which they showed as a little Westie dog, which is cute. Ursa Minor was a teddy bear instead of a real bear.
Okay.
Yeah, it came, what planetarium was that? It was
like
the major planetarium in Salt Lake City. Put them out in
okay,
1973.
sounds familiar. Oh wait, it's not Hanson.
Yeah, it was Hanson.
Okay.
I was going to say Hadley, but because
Yep.
I don't have it in front of me. But yeah, Hanson in Salt Lake City. So shout out to them for getting me on the track of being a amateur astronomer.
Mm-hmm.
And I also found all my space camp stuff from the early 1990s.
Ah, nice.
My jumpsuit, my hat, my pin, my manual, all that good stuff.
Uh-huh.
Yeah.
So you didn't go professionally astronomer, professionally astronaut, but you went
Yeah. I am not that good at math.
Okay.
And you know what? These days, it's actually really cool that there's a lot of astronauts going around. Like Drew Feustel from Michigan is one that I've seen him talk a couple of times, and they remind people that there's other routes into becoming an astronaut than straight up astrophysics or being a military pilot. Is that geology is a way, biology is a way, and it would have been kind of cool because I loved geology too, and I loved biology. I went to college for that, even if that wasn't what I stuck with ultimately. If I had kept that in mind. And I think that it's really good when you have these space professionals going out there and telling kids, you don't just have to go be a math and physics whiz. There are other routes. Yeah, you need the math and the physics, but if you happen to be, better at geology or better at biology or chemistry, you can still find your way into space.
Oh, definitely. It could be.
I kind of wish somebody had told me
that. Something like you can even be like mechanical engineering. They got that robot arm, the systems that need repairing.
Exactly. You don't even have to be a straight up scientist. You can have an engineering background.
Yep. You can have medical background.
Totally.
Hey.
Yeah, so there's a lot of different ways to get there, and I wish that had been more publicized.
Usually, you need. I've known some astronauts that have multiple degrees. So you have a degree in something, and then you apply to the space program, basically. But you kind of do it a little bit of both, I guess, too. I don't know. But there are definitely ways to get into the space program. And it's hopefully going to get a lot more lucrative and more demand for astronauts and technicians with more different types of rockets being built, and I'm sure there's going to be a lot more private missions into space, manned private missions, I wouldn't doubt.
Oh, yeah.
A lot of those will actually be corporate positions, I would assume.
Right.
So whatever it takes, kind of like, if you got a degree in geology, and sometimes a lot of people ended up working for the oil industry.
That's true.
That's where the good jobs were, as opposed to teaching geology in a high school. You can get some big jobs and some scientific backgrounds like that. Oh, let's see. A lot of stuff, a lot of articles all over the place. Kind of wonder, where do we want to go? Oh, let's just do some little observational stuff here. Next lunar occultation would be Gamma Capricorn by the moon on June the 21st, but that's going to be visible from the South Africa, and South Australia. So yeah.
Cool.
I think we still got occultation of Saturn and by the moon. I think it's on the 22nd. If I'm not mistaken. That's going to be visible from South Africa and the southern part of South America. I think that's on the 22nd coming up. Let's see if I can find it. Stellarium. I'm going to bring that up here and see if we can find out where the moon's at lately. Oh, I know what I was going to say. Yes, sky viewing, stuff like that coming up. Mars and Mercury are in conjunction right now. Really close together. However, that is close to the sun. So basically, it would be one of those better of daytime events.
Yeah, I was going to say, how early in the morning do you have to get up to see that?
No, it's in the evening.
Oh,
after the sun goes. Yeah, so it is possible to catch them, near the western horizon after the sun goes down. So you're going to have a super clear western horizon. If you have a go-to telescope, a little bit better. If you don't have to do any visual observing, but if you can put your go-to telescope pointed at Mars or Mercury by the computer and keep it tracking and wait till the sun goes down, and then get a view of them in twilight, like I said, or otherwise do a little bit of viewing in the daytime. Shouldn't be too hard to see. Mercury would be a little bit more prominent than the planet Mars in the daytime. So give that a shot. See if you can pull them out. Right now, they can't be more than got to be less than a degree apart. I think something like that. Let me check out their coordinates and see what I get an idea. Let's see. Declination 7 hours 39 minutes for Mercury, and declination for Mars is 7 hours 36 minutes. Okay, so 3 minutes of declination, and right ascension for Mars is 22 degrees 47 minutes, and right ascension for Mercury is 22 degrees 42 minutes. 47, 42, so yeah, so like 5 minutes apart in right ascension, and is that fractions of a degree in declination. They're pretty close. Definitely will make them worth it. So if you can find one, Mercury is about, I think it's, let me double check here. So Mars is 100% illuminated. Mercury is about 50% illuminated. So seeing Mercury halfway lit up, that's not so bad. It'll be a little bit bigger than when it's like really more behind the sun. It's got to be pretty close to at halfway lit up. It's got to be close to its greatest eastern elongation, farthest from the sun, basically. So it'll be medium sized and medium bright. So we should be able to pick it up in the daytime sky, and then just scan around towards the southwest. Really close, pretty much in the same eyepiece view. You should be able to pick up Mars there too. So that's a good way of being able to see two planets, two of the more difficult planets in the daytime.
Well, especially Mercury, yeah.
Yeah, Mercury and Mars. Well, Mars in the daytime can be pretty difficult too.
Mars is not particularly favorable right now. No.
No, it's pretty much on the far side of the sun. I think it said it was 100%. 98.4% illuminated, so that means it's pretty much on the far side of the sun. Yeah. So that means it's going to be pretty small. Let's say the size, elongation, illumination, phase angle, 14%. Let's see. I don't see where it says its actual size. Maybe it's here somewhere, but I just don't see it. All right. It's going to be small, though. All right. So that's the main thing after sunset. See if you pick those up. And then, of course, after the sun gets down, which is pretty late right now, like we start 9:30. It should be down by now.
Yeah, it's down. That's gone.
Okay. So about 8:30, 9 o'clock in the evening, something like that. It's hitting the sunset. That's about our latest sunset of the year. Not quite, but really close.
Let's talk about that once we get back from the station break.
All right, let's do that.
Indeed.
You are listening to Space Pirate Radio here on astronomy.fm. It is another Wednesday evening, June 19th, 2019, about 9:30 in the evening. For us here in the eastern portion of North America, daylight savings time. Universal time would put that at 1 o'clock in the morning, Thursday morning, June the 20th. So we're live for another half hour, and we have, of course, more programming coming up after Space Pirate. So stay tuned. I think we have the usual lineup of Astronomy Ireland, and then we had some Naked Astronomers, Planetary Radio, all coming up after Space Pirate Radio, so stick around. But this is the best time to come on over to our chat room and join the conversation. We've got conversations going in chat amongst people amongst themselves, or if you have a question for us, you can type it into the chat room. We'll try to read as best we can and answer your question as best we can live on air. So far in chat room, you mentioned your name. Yes, we have. You don't have to use your real name. We've got Aqua for you. We've got you and me. We've got Twist Edge, Glenn, Plaid Mac, Plaid Joan, Evil Spock, and Optronics.
Yep, and Black Projects bid us farewell right before the station break.
Yeah, it's a little late there at...
It's from the UK, so yeah.
2:30 in the morning. Yes, appreciate them staying up that late. So Black Projects is in the UK. We've got Twist Edge in Canada and Optronics in South America.
Yep.
We have an international audience,
yep,
as we usually do. We have about, our audience approximately is about $1,000 people a day. So that makes us basically over 300,000 a year listeners, by the way.
Very cool.
Mm-hmm.
Thank you all.
Indeed, yes. Oh, where was I going to go? Oh, let's go back to what's up in the sky. Because we got a little bit later, so same time that the sun is setting, we've got Jupiter rising. Jupiter being at opposition. Really, the ecliptic for the northern hemisphere is riding pretty low to our southern horizon. So Jupiter at opposition means that closest to the Earth, but for northern hemisphere observers, it also means it's lowest to our southern horizon. A lot more atmosphere to look at. Hard to get a good stable image of Jupiter, so you're going to have to do some experimenting and find some nice clear air down where our southern horizon, where Jupiter's starting to rise out of the southeast. Followed by an hour or so later will be Saturn rising. So you got the two big popular planets in the evening sky.
Oh, yeah.
After the sun goes down. And it looks like for tonight, about a half hour later, we've got the moon up there. Let me find out what shape the moon is in. It is 91.9% illuminated. That would be a waxing gibbous moon. No, wait. Are we past full moon? I lost track. Limited on the left side. Yeah, we're past full moon by a little bit.
Yeah, I was going to say, we had a waxing gibbous into last week.
Yeah.
I saw it over Kentucky. Very pretty.
Just started. So this would be a little bit past. Again, 91%. It's pretty close to a full moon. So this would be like a late full moon rising. And let's see what it says when it rises here at our local time. It rises at 11:30 in the evening. And sunset was about 8:30, 9 o'clock. So 3 hours later. So past opposition. So that would be a kind of a late full moon rising, like that historical mention that was for D-Day. A couple other things near Jupiter is dwarf planet number 1 Ceres.
Oh, what about her?
That's in Scorpius.
Nice.
The top 3 stars that make up like the head and the 2 shoulders of Scorpius, Akrab is the northernmost star of the 3 vertical, the ones that run north to south, basically. So Akrab is the northernmost one, and that's within a couple degrees of where Sirius is at. So go look for, our number 1. No, why is it labeled 1? It's 1 asteroid.
Well, it's the 1 asteroid, yeah. It's
yes, but it should be listed.
Why would it be the first dwarf planet?
Well, Pluto's the first dwarf planet.
But Ceres was discovered first.
Right. Well, that's true.
Ceres was discovered first.
Uh-huh. But it's got an asteroid designation, so maybe we need a number for dwarf planets. And how would you designate that?
How about we call them planets?
So designation is okay. So 1 Ceres means it's the first asteroid, which when it was discovered, it was considered a planet. And it was a planet for 50 years before it was downgraded to a minor planet asteroid. So now it has that at least on this chart, it has that one designation from the asteroid designation, but now it's a dwarf planet. So let's start this argument. Which one would be the number one dwarf planet? Would be Ceres being discovered first, or Pluto?
Ceres, no question. They went through similar trajectories. Both were discovered. Both were initially welcomed as full planets. Both were downgraded when other bodies similar to them were discovered. So Ceres is, to me, without question, the numero uno dwarf planet.
Okay. So Ceres was actually upgraded to dwarf planet. Yeah. Pluto downgraded to dwarf planet.
Well, Ceres was planet, asteroid, dwarf planet. So Ceres has done a yo-yo.
Mm-hmm. I saw a post on, the old Pluto argument. Well, it should be considered a planet because it was a planet for 75 years. I said, yeah, well, Ceres was a planet for 50 years.
No, I think they should be considered planets, but not because of, longevity. I mean, I just think that I still think the IAU definition is pretty lousy.
Mm-hmm. Yeah. So I always thought Pluto would be a traditional planet.
Yeah.
Even non-traditionally, it might be more of a dwarf planet, but traditionally, it could have been kept as a planet that way. So.
Yeah. But definitely, I don't think there's any argument you've made that Ceres doesn't take precedent.
Mm-hmm. So when somebody throws that argument about, out there that Pluto's a planet for 75 years, and then you could throw out that Ceres was a planet for 50 years. What about that one? Who feels sorry for Ceres now, like you do Pluto? Poor Pluto. Yeah, right. Just our naming system. All right, let's see where we want to go. Got something ready to go?
Oh yeah. Okay. So Mars has made some headlines this week. As long as we're talking about what's up in the sky.
Okay.
Okay, so we think of Mars as the red planet, right?
Yeah. Yes.
Well, it turns out there's some other colors.
Ooh, well, okay. Well, wait. Now I'll throw one out. We know about the white polar caps.
Yep.
I don't think you're talking about that.
I'm not.
We know about the wispy blue clouds, but I don't think you're talking about that. The green non-vegetation areas that look green from the Earth. I don't think we're talking about that. So what are we talking about? Is another color on Mars?
So sometime between September of 2016, which feels like a lifetime ago, and February of this year, something smacked into Mars.
Yes.
And it left a fresh impact crater that is blue.
Yes.
Beautiful, vivid blue.
I saw that article. One thing I didn't see mention of was how big is the central impact crater. So basically it's a classic crater right in the middle, but it's got a lot of spray to the outside, which makes it like 5-10 times the diameter of the crater itself. So I didn't see anything that mentioned the size of the crater itself in miles or less. Any ideas?
Let me see if some other sources have it, because no, the sources I read did not.
Yeah, I can't remember where that article was either that I read about that impact on Mars site.
I mean, all the usual science, internet science publications have run with it because it's cool. I mean, it is a pretty crater, and again, it's just sort of counterintuitive. It's like blue on Mars.
Yeah. So we don't have that many space probes to have caught
fresh craters.
Yeah, or the asteroid burn in. In through the atmosphere. So not enough cars for a good dash cam video on Mars yet. So that'll be coming around. Of course, we got Mars Reconnaissance Orbiter, and we've got one functioning rover, Curiosity. It's got to be pointing in the right direction, though, and it's got to be close enough to the impact site to be able to detect it. So not that hard to actually miss that impact. So there's kind of a wide range of when it could have happened. Could have happened.
It could be a couple months old. It could be a couple years old.
Could have been happening during that dust storm.
Exactly.
So only an orbiter might have picked it up, might not. And then it depends on how bright it was at the time and The size of the object makes a difference too. So I don't think anything's published on the size of the impact.
Couldn't find it in the articles I was perusing, but mostly they're interested in the pretty pictures, which are very pretty.
This is where we also throw this out to our chat room too. So anybody in chat room there can get on your computer and find out if there's an actual size for this crater. Be fun to know, and its location too. That would be helpful. Where on Mars it actually impacted. Yeah, and the Mars Reconnaissance Orbiter basically scans the smaller parts of Mars at a time as it's going around. So it's not actually looking at, it's pretty close to Mars, so it's not standing way back and seeing the whole planet.
Right.
So,
no, I mean it's taking high res photos. So
right. So it doesn't scan the whole planet all that often. Obviously they can compare photographs from a recent past to one passed by to one in the past, and if they see a difference, that would be noted. But I don't know how long it takes for them to scan the whole planet. It could be months, years if they're focusing on one region of Mars. So it would be pretty easy to miss. And its orbit too. Its orbit might not get to that exact same spot for a couple of years again. So, well, we'll figure it out. Somebody will come up with an idea of about how big that crater is on Mars when we get some more information on it. So recently, it was discovered more, I think, in April. So kind of recently discovered. The news just got out, but not really know when it was. And more articles will be printed, and we'll figure out how big that crater is. Let's see what I have one here on. Where is it? All right, here this article. Let me click on the article itself. Astronomers make the first detection of polarized radio waves in a gamma ray burst jet. Let me put this into our chat room here. Brand new stuff. So polarized light. Well, I don't know how you describe polarized light. You got a good way of describing? I've used it. You can use a polarizer, and if you hold a polarizer up in front of your eye and you rotate it and you look at the sky, you'll see sometimes the sky by rotating it, it'll get darker and brighter. The polarizer basically kind of like a grating. Not quite a grating, but kind of like a grating on a piece of glass or plastic, and it only lets through light that is aligned with the grill. So okay,
it allows in,
So okay, I'll try it this way. Let's say a fence. That's not chain link, but it's metal
flat
pipes.
Fence,
metal
fence,
pipes, okay? And pipe fence, yes. And you throw a frisbee at it. Okay, so if the frisbee is flat to the ground, it's not going to go through the gaps. But if the frisbee is tilted 90 degrees to the ground, it'll go through the spaces in the fence. That's the way polarized light goes through a polarizer. Or polarized light just travels through space too. So by aligning the grid with the polarized light, the light will come through. Turn it 90 degrees, the light will not come through.
Right, and you can do this with light in the sky, and you can do this with light on water. It's actually, you can see some shipwrecks that way.
Yep.
I think most people, their big experience with polarized light would be polarized sunglasses.
Yes, but I think not too many people have actually experimented with the polarized sunglasses that much. You actually take them off and you kind of rotate it so you can see some of the glare getting brighter and disappearing, brighter and disappearing. Better quality polarizing lenses are much better too. Yeah,
no, you can definitely have some fun with it.
Yeah. Where's my article now, though? So anyways, there we go. So they've discovered polarized radio waves. Okay, so radio waves is just basically a form of light coming out of gamma ray burst jets. They thought that gamma ray bursts come from massive stars that basically supernova explode and they go right to a black hole. And they'll have a jet shoot out of it, which is still kind of they're trying to figure out magnet. You thought maybe from magnetism there would be a jet coming out of this burst, and which they could detect with radio waves. But now that they've got the polarization, they're kind of figuring out, according to this article, that not that much of the light is polarized. So they're thinking that maybe there's not that much magnetic influence in those jets coming out of gamma ray bursts. So they found basically some polarized light, but much less than they expected. Less than 1% of the light coming from the jet was polarized. Yes.
Cool.
So, and where did I, just for audio listeners, this was from physics.org. Go there, check it out.
It looks like they were using the Atacama Large Millimeter Array down in Chile to follow up on something that the Swift Observatory found. So that's cool.
Yeah, part of this one was, it was where Atacama is in South America. This gamma ray burst went off right in prime viewing for that radio telescope system. So that's how they were actually able to get it, because gamma ray bursts, sometimes they don't last very long. Sometimes seconds or sometimes a couple hours, I think. So they're in a zone where the radio was, it was nighttime, it was in good position for the gamma ray burst to appear where above those radio telescopes. So they're able to got the reports, able to swing over and collect as much data as they could quickly before it faded out. That's how they got these observations. That's some of the real science of astronomy stuff out there.
Cutting edge stuff.
Cutting edge stuff, that's right.
So let's go back to some Stone Age stuff.
All right.
The kind of science that you could observe from a megalithic circle like Stonehenge.
Oh, which I wanted to ask that one in that site in Arkansas. The age of it, I know. Okay, so 1,500 years ago. No, it was in the 1500s. So 500 years ago.
Yeah.
When the Spaniards were there, that's when that culture was active. But do they think that site, those mounds, predate the Spanish?
No.
No.
Well, so it has the hallmarks, both pottery-wise, home-building-wise, and the mound itself, which was not a burial mound, but was an elevated mound on which the chief had his house, which is something that the Spaniards attest to in their chronicles.
Highbrows.
So this is the Mississippian culture. They did not leave a written alphabet or any sort of text. Okay. So we don't know what their language was like. We don't have any literature or oral traditions from them. But it was about an 800-year period from about 1800 of the Common Era to 1600 when they flourished, dominated a giant chunk of the interior of the U.S. down to the coast. They had trade routes. So they had copper artifacts down in Arkansas, which they sourced to the Great Lakes copper mines.
Okay.
They had shell artifacts that came up from the Gulf. So it was a sophisticated culture with, like I said, massive trade routes, very interesting, intricate pottery, and it kind of disappeared off the face of the earth. So this is not apparently a direct precursor to any of the tribes that we think of when we think about the southeastern U.S., the Cree or the Chickasaw or the Cherokee. Those came later.
Okay.
And it seems like the Mississippians just died out around 1600, probably from contact with Spanish-carried diseases.
Mm-hmm. Okay, so it was not that old, and it was still being used basically when the Spaniards were there.
So the earliest Spanish explorers, like Ponce de Leon and Hernando de Soto, they encountered people in what is now North America that future waves of settlers and colonists never encountered. No trace of them.
Mm-hmm.
And if not for sites like Parkin, we might think that, it's like, oh, they just made a bunch of stuff up, or, who knows. But Parkin just maps so beautifully to the historical record that we do have. That's like, hey, it actually is a snapshot of this culture right at its apex before something real bad happened.
Mm-hmm.
And, that they did have civil wars amongst themselves, too. That's one of the things that the Soto Chronicles talk about is this chief Kaski had a problem with Pakaha, the other chief down the road. And, it's like, so yeah, they kind of existed. They were an agrarian society that existed in a perpetual state of war from what we could reconstruct.
Cool.
Very interesting.
Mm-hmm.
So, Stone Age astronomy.
Yes.
Stonehenge and similar things. We are coming up on the June solstice, which is the exact kind of astronomy that you can do with a megalithic circle. So for those of us in the Northern Hemisphere, we are about to pass into what is currently reckoned as the beginning of summer. Of course, historically, it was actually considered Midsummer's Day, hence Shakespeare's, play, Midsummer Night's Dream. Mm-hmm. And down below the equator, it's going to be winter.
Yes. So, Northern Hemisphere, known as the longest day of the year, but not quite.
Not quite.
No, that's because how you measure the sun, well, and then the technical position of the sun. Technical position of the sun is based on the very center of the sun. And the sunrises and sunsets are based on the edge of the sun. So things can be a little off by a little bit for a couple of days right around the solstice. Solstice technically is in the Northern Hemisphere, the summer solstice would be the highest latitude of the sun. And it's really, since it's so close, measuring it exactly dead on precise is pretty tough to do because it's a ball of gas. So it's lumpy around the edges. So it's really, really, really hard to tell what's exactly the center of the sun. And it's not round. It's, it's a little squished in the poles and stuff like that. So getting down to the, millisecond of the summer solstice is really, really hard to determine. So basically the approximate center of the sun will be at the highest, well, I should say the highest, the most northern latitude. And the Earth is going around the sun, so that shifts the sun position. So we don't necessarily get the longest day of the year right at the solstice, but it's really close. Basically, you don't notice it exactly. But again, that's because the difference between the center of the sun and the edge of the sun and the refraction of the atmosphere, of Earth's atmosphere. When the sun gets down below the horizon, the sun can actually be technically below the horizon, but we still see it because the Earth's atmosphere is bending the image of the sun. It makes it look like it's above the horizon when it's actually below the horizon. So a lot of things contribute to the longest day of the year when it actually is close enough for the 21st, but the longest day, I can't remember if it's a little bit before or a little bit after the 21st. And then we get into things like leap years and stuff like that, too.
Yeah, and of course, exact timing also kind of depends on your position on the globe.
Yeah, exactly. Yep.
But for convenience's sake, we say that it's a day and we party.
Yes.
Or some of us party.
Uh-huh. So since the sun's reaching its highest latitude, that means from now on, every day, the sun will be at a slightly lower altitude and latitude on the meridian, which is the line between north and south passing straight overhead. So the sun's actually getting lower and lower and lower every day, but not really noticeably for the next at least 3 weeks or so. After a while, if you really look, if you got a good horizon, or if you have to have an ancient megalithic structure in your property and you're measuring these things as accurately as possible, you'll start to notice after a little while, I wish I had an ancient megalithic structure in my property. That'd be nice.
You could always build one.
That's true, too.
Parhenge, there's some people have done it.
Mm-hmm. Yep. Obviously, different cultures have done it. Recent people have done it. Some things are I think somebody in New Hampshire, I think it was, there's a sort of acclaimed Stonehenge, but most likely it looks pretty modern.
Yeah, the megalithic culture in what's now Brittany and the UK is like the pretty specific hallmarks. I mean,
yeah.
Though there's plenty of ancient observatories around the globe, but Stonehenge just happens to be one of the most notorious, at least for Anglophones like you and me. And it'd be cool. I mean, I'm sure people are going to be out there on Friday having a good time. Yep. And Optronics just mentioned there is an avenue in New York City that lines up with the sunset once a year. So that is totally true. There is a chance alignment in Manhattan where you can use the skyscrapers as your megaliths. So I don't believe it coincides with any of the solstices or equinoxes.
Some of them just happen to do that, unusual alignments. Mostly it's when the sun is out near the horizon. Yeah. I've seen anything with a long hallway. Sometimes they will get, that's a long hallway that's relatively east and west and doesn't have obstruction of the horizon. You can actually get the sun to go all the way down the hallway, and the sunlight will appear at the far end of it. So it's kind of fun looking for coincidental things like that, too. And at the North Pole, 24 hours of sunlight. In fact, all the way down to the northern Arctic Circle.
Yeah.
There'll be 24 hours of sunlight. So when you're standing at the North Pole, the sun will be, I think, 23 degrees above your horizon.
No, you can't really stand at the North Pole this time of year.
Well, that's true. You can stand on a ship.
Yeah.
Yeah. Passing polar bear, stand on its back, something like that. If you could stay there, the sun would basically go around the horizon at the same altitude, but it would slowly get into a lower and lower altitude until it actually was, you could even get it technically if you got, all ocean horizon, you could get the sun halfway below the horizon and go all the way around the horizon like that. So at the North Pole, you'll either have 24 hours of sunlight or you will have 24 hours of nighttime. Again, halfway sun doesn't give you an even 6 months of daytime and nighttime because the sun being halfway above the horizon, halfway below the horizon, kind of fudges things around a little bit like that.
Yeah, I've noticed that the birds are starting their dawn chorus at like 2 o'clock in the morning lately. So as much as we love having some sunlight here in Michigan after a long, dark winter, we can have a little more darkness so I can get a little better sleep.
Yeah, definitely. So kind of ruins astronomy. The farther...
yes, it does.
In the June here, the farther north you live, the less nighttime you have, and just the opposite for the southern hemisphere. Southern hemisphere, the farther towards the southern pole, the more nighttime you get. It's better for astronomy, but it's winter there too. So goods and bads. So that's how I always like the equinoxes for astronomy. Pretty much even day and nighttime, and the temperatures are moderate at the same time.
Yes, though we've had a fairly moderate June, thankfully.
Yeah, our spring people are complaining about being a little cold. Like, well, 50-something at nighttime, compared to we're going to have 80s and 90-degree nights coming up pretty soon. Don't complain about being in the 50s at nighttime, okay?
I love it. If it stayed in the 50s in the nighttime all year round, I'd be a happy camper.
Yeah, some countries are already hitting well over 100 degrees during the daytime.
My relatives in California are roasting. Yeah, it's sad.
Some kids, they're getting hit bad. All right, we've got just like a couple of minutes left.
Yeah, like a minute and a half.
Yeah, about a minute. I don't have any major news items right now. I don't think so.
No, I mean, my big one was blue on Mars.
Some studying some moon rocks real quickly. Just mention this one. So NASA they're trying to figure out some ideas of how the activities of the sun was about 4 billion years ago by studying moon rocks. So
moon rocks, the gift that keeps on giving to science.
Yeah, that's just our last little quick mention there.
And we'll be talking a lot more about the moon in the upcoming month.
That's right. All right, everybody, time for us to head on out of here. Appreciate everybody listening into our chat room and being a participant in our chat room. Don't forget, we're going to repeat this program and more programming coming up after Space Pirate Radio, all in 4-hour blocks for the next 24 hours. So time for us to head out. Good night, everybody.
Good night. Clear skies, y'all.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is astronomy.fm radio.
AFM.